We're going to look at a couple of word problems. Tonight we're going to look at a couple of word problems which involve solving a system of tangent equations in two variables. So the first example is to measure the height of a rock formation. A trigonometry student first measured an angle of elevation of 57 degrees. So they don't know the height of the rock formation. So we'll say that angle of elevation to the height of the rock formation is 57 degrees. They want to know the height of the rock formation. So here's the picture we're creating. Then they stepped back 8 feet and measured the angle of elevation again, which is naturally a little bit lower at 48 degrees. How tall is the rock formation? So that's my value of x, what I'm trying to find. If I look at the situation, oh, by the way, it does say the student is 5.5 feet tall. So whatever we get at the end, we will have to add 5.5 feet to. 15 feet here. If I look at the first angle of elevation, I don't know the opposite. I don't know the adjacent. I'm going to call it y. I can set up a tangent function. So the tangent of 57 degrees equals the opposite over the adjacent for the smaller right triangle, this being my beautiful rock formation. For the second angle of elevation, the tangent of 48 degrees is equal to the opposite x over the adjacent, which is y plus 8. If I cross multiply these two proportions, because trigonometry is nothing but similar triangles, I get y tangent 57 is equal to x, and for the second tangent equation, y plus 8 tangent 48 is also equal to x. Due to the transitive property, if two things are equal to x, those two things are equal to each other. So this expression, y tangent 57, must equal this expression, y plus 8 tangent 48. So I'll set them equal to each other. Y tangent 57 is equal to y plus 8 tangent 48. If I distribute on the right side, because apparently my goal now is to solve for y, just like in a linear system, solve for one variable and then substitute it back in to get the other, but we have a tangent system. Y tangent 57 is equal to y tangent 48 plus 8 tangent 48, distributing the tangent 48 through the parentheses. And note, remember we said it was much easier to write the coefficient before the function, less confusing that way, no chance of multiplying the angle by a number. I'm going to bring my y tangent 48 over to the left side and attempt to isolate the variable y. So that will take a little subtraction, and then on the right side I have 8 tangent 48. And then over here I'm going to factor out GCF of y, further isolating the variable of y. And being the algebra geek that I am, rather than going decimal at this point, I'm going to just go ahead and solve for y and say it's 8 tangent 48 divided by the tangent of 57 minus the tangent of 48. Now keep in mind, tangent 48, that's just a ratio of two sides of a triangle, so that is a number. So is tangent 57, and so is tangent 48. So I can just calculate this in the calculator to get the value for y. So pulling out my calculator, let's clean this up a little bit. I am going to find first the 8, first check that it's in mode of degrees. We're good here. All right, I'm going to find 8 tangent 48, which I get as 8.8849. I always like to go to 4 decimal places until right at the end. Then I'm going to find the tangent of 57 minus the tangent of 48, and I get 0.4293, rounding that. A little division, 49 divided by 0.4293. I get 20.696 as a value of y. Don't forget, that's y. We're solving for y here. Okay, so we have y is about 20.6, 20.7 approximately, which means if I look back at my equations that were set up, I could put the y in this equation and solve for x, just as with a linear system, find one variable, substitute, find the other. Or in this equation, I'm liking this one, it's a little bit easier. So I'm going to put that y value of 20.6 up here. 20.696. I'm a stinker for accuracy. So if I cross multiply, I take that and multiply it by tangent 57, I get my value of x. So I still have it in my calculator here. So 20.696 times the tangent of 57 is what's right here if I cross multiply it. I get that x is 31.869, or about 31.9. So x is about 31.869, or 31.9. Don't forget, the person who is observing these angles of elevation is 5.5 feet tall. So to get the total height of the rock formation, I do have to add that. So I'm going to add 5.5. And I get 37.4 as my final answer. Approximately 37.4 feet tall. So that's the solution. I have a second example here, which you may want to try on your own before we go over it together. And it says, a 1.8 meter tall trigonometry student, if I could get this a little less fuzzy, wants to measure the height of a flagpole in front of their school. They first measure the angle of elevation to the top of the flagpole as 68 degrees. Then they step back 3 meters and measure the angle as 50 degrees. How tall is the flagpole? I would encourage you to pause the video now and try it on your own, and then come back. So we're going to solve this one a little bit quicker. We want the height of the flagpole at the school. They first measure it at an angle of elevation of 68. They step back 3 meters, and they measure it at an angle of elevation of 50 degrees. Be wary if that angle doesn't get smaller as they step back. And the observer is 1.8 meters tall. If I set up my tangent system, the tangent of 68 is equal to A over B, opposite over adjacent. The tangent of 50 is equal to A over B plus 3 for the large right triangle. So we have that small right triangle, that large right triangle as well. Cross multiplying each of these proportions gives me B tangent 68 equals A, or B plus 3 tangent 50 equals A. Using the transitive property of equality, they're both equal to A, so they are equal to each other. So it looks like I'm going to get the length of B before the height of A, so I'm going to go ahead and solve for B by distributing the tangent 50 through the right side. Move that B tangent 50 over to the other side with a little subtraction. And then factor out the B from the tangent functions. Which means the value of B is 3 tangent 50 divided by tangent For some reason, my tangent of 68 became a tangent of 60 as I was working this out. So I'm going to go back and correct that. Tangent 60 minus tangent 50. Tangent 68. I'm still doing it. All right, so now that I know what b is equal to, I get my calculator and calculate 3 tangent 50, which is 3.5753. And tangent of 68 minus tangent of 50. Very important to end the parentheses on that. I get 1.2833. Finally, dividing. I get that b is equal to 2.7860. So b is approximately 2.8. Now that I know b, I can go back and find a. B is approximately 2.8. So that means right here, b is 2.8. I can multiply 2.8 times tangent 68 to get a. 2.8 tangent 68 is 6.93. That is the height of the flag above the observer's point of view. Since the observer is 1.8 meters tall, I will add that on to the 6.93. And I will get a total height of 8.7 meters. How tall is the flagpole? 8.7 meters. And that is the second example on solving a system of tangent functions.